All right, please excuse my voice. I have a little bit of laryngitis going on. So we're going to continue on in our look at exponential functions. So we've been looking at things like, say, 3 to the x power, and graphing them, evaluating them, and so on. But what if I wanted to solve for the exponent, meaning like if I had 5 to the x power equals 625, how would I evaluate that? Now in some cases, like this one, okay, I know if I look at my the perfect numbers chart that we filled out, I know that 5 to the 4th power is 625. So I know in this case x is 4. Okay, but if I get a little more complicated, we might have to look at rewriting them in order to solve, or coming up with a completely different way in order to solve for x in the exponent. So let's look at B and C. All right, so these two I can rewrite. So what I mean by that is I know that 4 is a power of 2, so I could rewrite this as 2 squared raised to the 2x on the right side, and 1 over 8 would be like 1 over 2 cubed, or 2 to the negative 3rd power raised to the 3 minus x power. Now I know power to a power means that I am going to multiply these. So I'm going to take this times this and this times this. And since they are now both the same base, I can just set the powers equal to each other. So that's going to give me negative 3 times the 3 minus x must equal the 2 times 2x. So that's what? Negative 9 plus 3x is equal to 4x. Subtract the 3x over, and I get x equals negative 9. So rewriting this, if I put them in the same base, then the exponents must be equal to each other. That'd be like saying 2 squared is equal to 2 squared, and so on and so forth. So if I rewrite the next one, C, okay, I can rewrite 1 over 100 as 10 to the negative 2 power raised to the x plus 3, and in order to get 1, I can make that 10 to the 0 power. So I'm going to solve by multiplying this through and setting it equal to 0. So that's going to be negative 2x plus negative 6, so I guess that'd be minus 6, is equal to 0. If I add the 6 over and divide by negative 2, I get x equals negative 3 for that one. The problem is, though, what if I have a problem in which I cannot actually rewrite it so that they have the same base? 2 to the x equals 6. 6 cannot be written as a power of 2, at least not with a pretty number in the exponent like 2 or negative 1/2 and so on and so forth. It's going to be some kind of weird decimal. So that's where we get into the need for what we call the inverse function of an exponential. We're going to call this a logarithm. Okay, so we use logarithms, and we could have used logarithms to solve A through C as well. We're going to define it as log, just for short of logarithm, base b of y. Okay, so if I wanted to take 2 to the x equals 6 and rewrite it in this logarithm form, I would have log base 2, because that is the base of the exponent, of the y value, which is 6, is equal to my exponent. And I would have to use my calculator in order to evaluate this. To get an actual evaluation, you would hit Control-Enter and it would give you out the decimal. Let's look at a couple where I just have to rewrite it into logarithm form. Remember, that's log base b of my y value is equal to my exponent. Okay, so in this case, for A, I have log base 5 of 15,625 is equal to 6, because 5 to the 6th power is 15,625. Likewise, log base 3 of 1 is equal to 0. And you're going to find it doesn't matter what the base is, anything to the power is 1, so log base anything of 1 is equal to 0. Okay? For C, log base 1/2 of 8 is equal to negative 3. And last but not least, log base 12 of 12 is equal to 1. Now, in order to evaluate these on your calculator, if you look on your calculator, you're going to see next to the number 1, there's a 10 to the x and an e to the x. Above those buttons in blue are your logarithms. So if they're in blue, that means I have to hit the blue button, the control button first, and then I can input my information. Just so when we get there, you can actually evaluate. All right, so let's go the other way. Let's go ahead and rewrite, if it's given in log form, take it back to exponential form. So I'm going to always have the base first. 3 to the second power is 9. 27 to the 1/3, which remember 1/3 power means cube root, so cube root of 27 is 3. 1 over 4 to the negative 2 power is 16. And 2 to the negative 1 power is 1/2. So you should be able to go forwards or backwards, and I should be able to plug these into my calculator, like A, B, C, or D in example 1 here, in order to evaluate. All right, so we're going to do just that. You're going to get out your calculator. I am going to rewrite the first couple because we can just solve them ourselves. I'm going to set this and say this is equal to some number x. So I'm going to put it into exponential. 4 to the what power gives me 64? X equals 3. Okay. 25 to the what power, if I set this equal to x, 25 to the what power gives me 5. Well, the square root of 25 is 5, so that means x is going to be 1/2. Okay, 7 to the what power, or we'll set that equal to 0, is equal to 1, and that's x equals 0, and so on and so forth. So I want us to use our calculator for the next 3. Just for the practice. If I rewrote it in exponent form, it would be this. And off the top of my head, I don't know that answer. But if I type it into my calculator, I got out 2/3. Okay, if I type this one into my calculator, I got out -1. And if I type this one into my calculator, I get out 6. So we have a couple of different logarithms we can use, all right? So all of the ones we've done so far have a base of some number. We call the common logarithm if it's base 10, and the natural logarithm if it's base e. When you get into science classes, more often than not, you're going to be using the natural log is what we're going to call it, okay? So a couple of things. In your calculator, since you can put a base, you can always put the 10 in, but you don't have to. You could just arrow over and put your number in. It'll automatically change it to a base of 10. Okay, and log base e, we're going to rewrite it with to represent natural log, ln of x. All right, so using our calculator, if I type in log of 8, I get about 0.903. If I type in log of 30, I get about 1.477, and so on and so forth. If I plug in natural, now this one's natural log of 0.3, I get -1.204, and natural log of -2. Okay, if you type this into your calculator, you're going to get an error because there is no solution. And the reason for that is if you think about exponential form, natural log is base e, so it's e to the what power gives me -2. There is no exponent that I can raise e to that's going to magically make it negative. So that can't happen, which means I cannot take the log or natural log of a negative number because it is not possible to get an answer. All right, so we just did this, so I don't need this space anymore. All right, so one property that we need to know is that if I have log base b and then of something with the same base in there, that it's just going to cancel that stuff out. Likewise, if I have b raised to a log base b of something, I cancel out the log and the base. So for example 5, log base 8 of 8 to the 5th, the log base 8 and 8 cancel, and that's just going to leave me with 5. Log base 5 of 25 to the x. Okay, so now these aren't quite yet the same looking as far as our bases, but if I rewrite that as this, okay, oops, that should be an x. That's going to give me log base 5 of 5 to the 2x. So that's going to simplify down then to 2x. Okay, and then 10 to the log of 4. Now remember, log without a base is a base 10, so the log and the 10 cancel. It's going to give me 4. And 49 to the log base 49 are going to cancel out and just leave me with the 7x.